This lesson today is all about triangle inequalities. So I'm having flashbacks here to my childhood. Actually, these toys are more what my youngest brother would have played with. My toys didn't have color back then; everything was just black and white. But he played with these, and you could make structures with these. The idea was that every time you had a triangle, it was a rigid construction, and it wouldn't flop around. So remember, triangles are always in our constructions. I want you to notice that the yellow rod is one half the length of the green rod. The blue rod is one half of the red rod. And then you can notice right here that this is not going to be a triangle. There is no way you can construct a triangle using these three rods. The yellow won't connect. So there must be a limit, either on a minimum or a maximum in terms of the size of rod for the third length or the third side. And so this lesson is all about discovering what that is. Notice in the construction of bridges, the length of these spans is very important. Too long, and they won't lie flat, so you can cross the river. Too short, and they won't meet, and there'll be a gap between them, and you can't cross the river. Let's talk about the triangle formed by the two pencils and that black line. The line, let's say, is always going to be a part of this triangle. And the vertices for this triangle are on that line. It's where the points of the pencils, the red and green pencils, meet the line. The other vertex is where these two pencils meet. Notice that if I change the position or the size of the side on that line, maybe it's a segment. There we go. The angle created by the two sides here gets smaller. As I increase the size of that side, I'm also increasing the angle created by the other two sides. So you know there's a relationship between the length of this side and the angle that is opposite it. Take a look at the scissors. Just make sure that I don't cut off my finger here. But the triangle formed by the ends of the scissors and the sides of the blades of the scissors and the line here. Would you shrink that side? We're also shrinking the angle that's inside the scissors. Okay? Can't help but do that. Now, this is true of every single angle inside the triangle. You shrink a side, you are shrinking the angle that is opposite it. This gives us an opportunity to determine where the largest angles and the largest sides are. Now, in this triangle, we have the green side B, the red side A, and the black side C. The largest side here is C, and it is opposite the largest angle. I can measure that with a protractor. I know that already is obtuse. These two are acute. Largest angle, opposite largest side. Smallest side, opposite the smallest angle. And the one in the middle, the side in the middle, the side that's neither larger nor smaller, is opposite the angle that's also between the smallest and largest angle. So we can order these from smallest to largest. Remember the convention for labeling a triangle. Sides or parts of lines are lowercase. Points or vertices are capital. And in this diagram, we would have the vertices A, B, C opposite the sides A, B, and C. This is a convention that's usually a standard that keeps things straight. Also, just good to relate the opposite side A, angle A, vertex C, opposite side C, and so on. Now, this is a question you'll see on a test. In this question, it's asking the lengths of the two sides of triangle 11 and 25, what's the length of the third side? Well, you're going to have a range because you don't know if 25 or 11 are the largest or smallest sides in that triangle. So in order to find the range, you need to consider the fact that if 25 is the largest side, then 11 and that third side must add to something more than 25. If 25 is the largest side, sorry, we already did that one. If 25 is the medium-sized side, then 25 plus 11 must be greater than the third side in order to make a triangle. So let's find that range. So it's quite simple. You just look at it as the difference in the sum of the two values. What is the difference between 2511 and what is the sum of 2511? Well, one gives you 14 and one gives you 36. These are the bounds, upper and lower bounds of the third side. The third side must be between 14 and 36 centimeters, and the only solution is 25. Another way of writing this is that the solution set for that third side must be between, we can say X is between 14 and 36. Larger than 14, smaller than 36.